Hi, good evening, everyone. How are you?
Fine, sir.
Fine, sir.
Fine, sir. How are you?
Yes, I'm
Fine,
doing
sir.
good.
How about you?
Fine, fine, fine. Thank you all. Okay. How is the Josh?
Hi, sir. Hi, sir.
Nice. How's the Josh? Ritvik?
Fine, sir.
How's the Josh? Mohit?
Hi, sir.
Good. How's the Josh? Krishna Pranav? Today, Akshara, today you will get today.
Okay, sir.
Today you will get it. Okay. After the class, immediately we'll get it.
Okay, sir. Thank you.
So what about the results, sir? My
Yes, yes.
result is
Yeah, that is what. Today only, today you will be getting. Okay, 1 second. We got that. Yes. So we were going with real numbers. Am I correct?
Yes, sir.
Yes. And we were solving a couple of questions based upon that as well. It's a very pretty simple topic.
Yes, sir.
Okay. Chalo. So let's get started without any delay. So yeah. So any doubts of yesterday's question paper?
No, sir.
Any doubts? See, after posting the results, I'll be discussing the question paper. So today we will go with real numbers. If any well, today maximum I'll be finishing real numbers. If at all anything we left with, then we can go for that. Okay, we were going with the rational number, irrational numbers as well, right? We were talking about irrational numbers, right?
Yes, sir.
Correct?
Yes, sir.
So just a minute. Amatullah is joining now. So till what we discussed, rational numbers, irrational numbers, right? Yes. What do you mean by irrational number?
The number that cannot be represented in the P by Q form, where P and Q are integers and Q not equal to 0.
Yes. So number which cannot be written in the form of P by Q, and P and Q are integers and Q shouldn't be equal to 0. Okay, this is the condition everyone knows. And what are the examples?
Root 2, root 3.
Root 3, root 2, 5.
Yes, sir.
Okay. And what is the value of E? E value is E is a constant. Value of E is 2.7718, something it will be there. It goes on. It is a non-terminating decimal. Okay. Non-terminating, it goes on like that. Even pi also. Even pi also 3.14 something. It will be, even you solve for years and years, it will not get over. It will not get end. It will not terminate. Okay. It is non-terminating. So these are irrational numbers we have learned so many times. Okay. So now tell me one important note here. One important note. Look at this beta here. Root P is irrational. It is irrational when P is a prime number. It is a irrational number when P is a prime number. When P is a prime number. For suppose, for example, root 7. Okay, root 7. Root 7 is what? It's a prime number. So, sorry, 7 is a prime number. Root 7 is what now? That is the reason it is an irrational number. Okay.
So all prime numbers are irrational numbers, sir.
Sorry?
Sir, so all prime numbers are irrational
All
numbers.
prime numbers are, yes, all the prime numbers are rational numbers. Now, how can you say this? How can you prove this? Look at this here. For suppose, let's say, we assume that, for suppose we assume this is a true statement. Okay, let's assume.
Sir, root 7 is equal to P by Q, sir.
Sorry,
Sir, can I try this question because I did it today?
I can't hear you properly. Can you speak loudly?
Sir, can I try to tell this question like as I did it today?
You want to explain this?
Yes, sir.
Yes, please.
Sir, can you repeat?
Yes, I'm saying that root 7 is a irrational number. All the prime numbers are, all the prime numbers are irrational numbers. I'm saying, see, how can you prove that? In this, by using, we have a method called contradiction method. Contradiction method. So by using contradiction method, we could prove this basically. So that's what I told you. You are saying that you want to give a path. How can we prove this? Yes, you can tell me. Yes.
Yes, sir. So basically,
Speak
now
loudly.
we can
Keep your microphone in front of your mouth so that I could hear you properly.
yes, sir. So in this, what I'm
Your voice
saying
is
is,
low.
sir,
Still your voice is low.
just a second, sir. Oh, yes, okay. Can you hear me now?
Yeah.
Yes, sir. So what I was saying is, sir, we can assume root 7 as P by Q form, in the P by Q form.
It's a rational number. Okay.
Yes, sir. If it's a rational number, we can assume root 7 as P by Q in P by Q form and squaring on both sides. So which will become 7 is equal to P square by Q square.
Mhm.
And then, sir, we can say P square is equal to 7Q square.
Okay.
And, sir, we get that. And then after that, what we can do is, sir,
7 divides p square and also the next step.
True.
So, the next step is we have to substitute p value as we are taking 7, right, sir? So 7r. So 7q square is equal to 7r.
So 7 divides both the things. So 7 is a common factor.
Q square. Yes, so as p and q are co-primes, we have to mention in the second step, sir.
Yeah. Yes. Look, let me tell you. Very good, Mohit. Very good, Harini. Good. So I'll explain you. Everyone listen to me. Let's assume that it is a true statement. And what we do here is, see, and we arrive to a statement where our, where our result is a contradiction. So look at this here. And we do one thing. For suppose example, we consider root 7 is a rational number. Okay. See what we took. See, we arrive to a stage where our statement, our assumption, like which contradicts our assumption. This is our assumption, right? We assumed that the statement is true. We arrive to a state where our statement is contradicts. Our statement itself, our assumption itself contradiction. So for that, we do one thing here. Root 7 is a rational number. Okay. So what we assumed, we What the assumption? What we assumed? Assumption. What is our assumption, beta?
Root 7 is equal to P
One
by
second.
Q, sir.
Root 7 is a, we have to prove that. What we have to prove? Prove that root 7 is a,
Irrational.
let us write, prove that is a irrational. Irrational. Perfect. What is our assumption? We assume that the statement is true.
And it's irrational. It's rational. It's an irrational number.
Yeah. Root 7 is a rational. We assume like this, rational. Okay. How come it is possible? Our assumption is root 7 is a rational number. Okay. Very good. Now, I think someone is in the waiting room. Yeah. Okay. So now look at this beta here. As you told that it is a irrational number is nothing but root 7 can be written as a by b. So squaring on both sides. So 7 is equal to a square by b square. Correct? Isn't it? So a square can be written as 7 times of b square.
Yes.
Isn't it? Understood my point? Here what's happening here? Here 7 divides a or not?
Yes, sir. It's
First of all,
divided.
yes, it's divides. So can I take like 7 is equal to AC, something like this? B square is equal to, if I take B square is equal to C, can I write like, one second, let us write like this. For suppose, you write like this. So hence, you write here 7 divides A or not? Then there exists a number C such that I'm proving, guys, how a number C such that A is equal to 7 times of C. A is equal to 7 times of C. Correct? Because here 7 divides A is nothing but A is equal to 7C or not? Can I write like that?
Yes, sir.
Then how can I write like this now? If I do squaring on both sides, again what happens here?
Sir, a square is equal to 49 c square, sir.
A square is equal to 49 C square.
C
If
square.
I do squaring on both sides. Hope everyone is understanding here. Okay. Fantastic.
Yes, sir.
Now, similarly, what can I write beta here? A square. A square, we know that A square is equal to what now?
7b square, sir.
Yes. So 7b square is equal to 49 C
C
square.
square.
C square.
So,
One side.
just a minute, children. Just a minute. I'm getting. Yes. So 7b square is equal to 7b square is equal to what beta? 49 C square. Correct? So now can I write this as 7177?
So b square is equal to 7c square, sir.
Very good. 7C square. This is what I got here. So beta, hence what is happening here now? What is the meaning of this?
Sir, again 7 is dividing.
Again 7 divides B. Again 7 divides B or not? From this,
Yes, sir.
7 divides B,
B.
which is nothing but C.
B is
7 is
equal
what
to
common factor
70,
for A and B or
sir.
not now? Look at it here. Here. One second. Let me. This is the first equation. Let us consider this as a second equation. So from 192, can I say that 7 is a common factor for both A and B?
Yes, sir.
Yes, sir.
HCF is 1.
Yes, can say that 7 is a common factor for both A and B. Correct?
Yes, sir.
But 7 divides A and B, which is nothing but it contradicts our statement, our assumption. Correct?
Yes,
Look at
sir.
it. How it is contradicts? Look at it here. It contradicts our assumption that A and B are
Co-prime,
co-prime
sir.
integers. Co-prime integers or co-prime numbers, you say. So our assumption, what was the assumption? Our assumption that, what was that? Root 7
Root
is
7 is rational,
rational.
sir.
Is a
Is wrong.
rational.
Is wrong.
Is wrong.
Therefore, root 7 is irrational number. Correct? 7 is a common factor for both A and B. So it contradicts our statement that A and B are co-prime numbers here, co-prime integers. Isn't it, beta? So can anyone of you explain me what I wrote in the last 5 lines?
So can I?
So can I try?
1 minute. I'll give, yeah, please, 1 second. Bhumika, can you explain me this?
Just a minute.
Yeah.
So co-prime means other than 1, they do not have a common factor, but it has a common factor 7. So it is not co-prime.
Okay.
So our assumption is wrong.
What do you mean by co-prime?
We have only 1 as a common factor.
Yeah. Highest common factor is 1. Co-prime number is nothing but what? See, highest common factor must be 1. That is co-prime. Or you say that 2 numbers are co-prime if there is no common factor other than 1. Yes. They do not have any common factor other than 1. You are right. Okay. Tell me.
But 7 is a common factor between both of them.
Yes, both of them.
So that means they are not co-primes.
They are not co-prime.
So they're not in the P by Q form.
Here, 7 is a common factor for both A and B. It is contradicts our assumption that A and B are co-prime integers. Now tell me, Mohit. Mohit, you explain this.
Yes, sir. So I also did it almost in the same way, just a bit different, sir. So, sir, as I told, root 2 is equal to P by Q, and when we're squaring on both sides,
Yeah, I understood all the procedure. I understood. You explained that. Where you gone here is somewhere you gone somewhere here. Yeah, you disconnected some.
Yes, sir. So over here, sir, when we're taking P square, like we can take P is equal to 7C, sir, as 7 is a factor of P. And then, sir, we can again square on both sides, and it becomes P square is equal to 4C square. And yeah, so therefore 4C square is equal to 2Q square, sir.
Hmm.
And then after that, sir, we get it Q square is equal to 2C square. And since 2 is a fact, Q square is equal to 7C square, sir.
Hmm.
And sir, again, when we get it, 7 is a factor of Q square. So then Q becomes 7D, sir. 7D this time.
Okay.
And then again squaring on both sides. So Q square is equal to 49D square. And here we get it as how much? 7C square is equal to 49D square, sir.
Mm-hmm.
With that, we get C square is equal to 7D square, and from that, we can get it as root 7 is equal to P by Q, which is equal to 7C by 7D.
Mm-hmm.
But, sir, as per our assumption, we had to get P and Q as co-prime numbers.
Mm-hmm.
And since we didn't get it, root 7 is irrational.
Yes. Here, as per our assumption, what we that root 7 is a irrational number. I'm proving that. So what is our assumption, beta? Root 7 is a rational we took, which is nothing
Yes,
but
sir, we
A
took
and
rational.
yeah. But as per assumption, what it must be? What it should be?
Co-prime, sir.
Co-prime.
Co-primes.
Clear? It must be co-prime. But look at this here. What's happening here? It contradicts our assumption that A and B are co-prime, isn't it? Is it contradicting or not? It has common factor. Co-prime number is nothing but what? It must have
Only one is HCF.
one as a HCF. HCF must be one. It must have common factor as one. Other than one, it not to be like you need not to have anything. So that is the reason. What's happening here? It is contradicting our statement. We can say that root 7 is a rational. Is wrong. Then absolutely I could say that root 7 is a rational number. Hope it is clear with everyone, boys and girls. Understood?
Yes.
Any doubts?
Sir,
Think don't
so
remember
what
anything.
is the what is the exact meaning of contradiction? What it means?
Contradiction is nothing but like you say controversy. You know, controversy. What should I say? I'll tell you in Telugu.
Yes.
Basic contradiction ante vairudyam, like you say, like against. You say against. Understood my point?
Okay. Yes, sir.
Like against
Viruddham.
it's not exact, but like you know, if you have a debate, like you know, you might oppose me, I might oppose you, like it become big contradiction.
Yes.
Understood my point?
Yes.
Like,
Yes,
you know,
sir.
so you say yes, you can say like difference, conflict, dispute, inconsistency. These all like you can say all the same meaning. It gives all the same meanings. Clear?
Okay. Okay, sir.
Okay, chalo then. Okay, we will go with the next concept. Hope it is clear with everyone, guys.
Yes, sir.
Yes, sir.
So now rational numbers. Let's talk about rational numbers, and this is also one more concept we have here. Rational numbers.
Okay, sir.
But a rational number is nothing but what? A number which can be written as in the form of p by q. A number which can be written as in the form of p by q, and where q shouldn't be equal to 0. Correct? So let's say that minus 1 by 2. Any number you said 3 by 1 or 5, like minus 5 and etc.
Excuse me, sir.
Yes.
Sir, irrational numbers, sir, I mean, they cannot recur, right, sir?
Sorry.
Sir, irrational numbers are non-recurring, right?
Yes, non-recurring decimals.
Sir, and we say pi as irrational, sir, but if we divide, sir, it is recurring, no, sir.
No.
3.142857 recurring.
Who said no? What is the pi value? Tell me.
So
See,
22 by 7.
No. What I'm saying is decimal.
It's a 3.1516.
No. Wait. I'll tell you. Look at it. First of all, look at it. 22 by 7, right? So 3.7173 is 24. So 21. One remainder. So 10 becomes 7 ones. Again 3 remainder 7.14, and again it becomes 10. So 7 ones. Again it becomes 3. So 4. So 7 fives, 7 nines, 7 twos, 7 6, 7 5, 7 threes, 7 fives, again some, it goes on like that. It goes on. Even you solve for 10 years, it never ends, which is nothing but what? Who said 3.14 exactly? See, for up to 2 decimals we take Vivek, up to 2 decimals we
Yes.
take simply it as 3.14, but it is not meaning that, it doesn't mean that it is terminating there. Understood my point?
No, sir, like when I divided, I got it like 3.142857 recurring, so that's all.
No, it is recurring.
Yes, sir, it is recurring.
Yeah, 1 second.
So
Let us divide it properly.
So let's since 22 by 7 is in p by q form, it will recur, right?
Yes, look at this
Yeah.
here. Yeah. So 1 second. Let us divide properly. So 3.14. Yes, definitely. So what is the value of that? It never terminates basically. It never terminates. What happens? Look at this. If your digit pi never repeat, beta. Look at this here. Pi, the digits of pi never repeat. So what I'm trying to say is, because it can be like it can be proven it as like irrational number, right? And 1 second. Let me write it as, my pen is not working. Kya karu abhi? 1 minute. No, pen is not working. Can you give me another pen? No, no, change it. Like in that box, check that box. Check that box. Okay. Let me check once. Now, can you see, guys? Yes, it is writing. Guys, look at this here. Basically, look at this. What is the meaning of non-terminating and non-repeating decimal? Tell me. See, non-terminating, you must know first what is non-terminating. You must know what is non-terminating. Non-terminating, non-repeating is nothing but what? Oh, I must write somewhat neatly so that everyone understand. Non-terminating.
So non-terminating in the sense it goes on repeating. So bar will be coming.
Yeah. Non-terminating, non-repeating decimal. What is the meaning of this? The meaning of this is a decimal number that continuously, it continues endlessly. I mean, it keep on goes, it never ends. Okay, with no group of digit repeats over here. Understand my point? So for suppose, let's say for that example is what? Pi. We write it as like this. Which value? The value of that is 3.141592 92 5 3 again 5 8 9 and goes on. It goes on like that, beta. Okay, it goes on like that. So and you take e. Just now I told you that e. What is the value of e? E is what? This pi value is what? Non-terminating, non-repeating decimal. Look at this here. It is non-terminating. It is never terminates. It never terminates. It never stops, and not repeating as well. Vivek, understood my point? It is not terminating as well as it is not repeating as well. Check. Is there anyone check? Is there anyone repeating here? No. And e, what is the value of e? E is a constant. The value of that is 2.718, 2.2818, something. It goes on. It is also what? It is a non-terminating and non-repeating decimal. Okay.
Yes.
So like for our convenience, we have taken pi as 22/7.
Yes, for our convenience, we take it as 22/7, and we take up to wherever you get better, up to 2 decimals you can take, whatever the value. Look at this. For e value also, what we take here is 2.718. We write up to 3 decimals. If for our convenience, we take up to 3 decimals. And here also, if you want to write 3.141 or 3.14, we take up to 2 decimals is fine, but like maximum, zyada se zyada you can take like this. Clear? Non-terminating,
Yes, sir.
non-repeating decimals can be easily created by what, beta? Using pattern. So for suppose, look at this here. You can create by using pattern. You say, there are some pattern, beta. Look at this. You say, any pattern. You say 0.10, 100, 100, 100, 14 zeros, 15 zeros, 16 zeros, 17 zeros. It is a pattern. Look at this: 10, 20, 30, 40, 50, 60, 70. It is a pattern. It can be created. A non-terminating, non-repeating. What I meant to say here: a non-terminating, a non-repeating decimal can be easily created by using a pattern. There will be some pattern. Clear? Understood my point? Easily created by pattern. Yes, very simple. But
Yes, sir.
like you will not be using this much. But I'm telling you. Clear? Understood now? Any doubt here? Understood. Pi is what? What is a pi? Pi is a non-terminating, non-repeating. Non-terminating is nothing but, again I'm telling you, it never ends. It never terminates. Terminate is nothing but ending. Non-terminating is nothing but not ending. Very simple. Non-repeating. Non-repeating is nothing but what? Not repeating is nothing but it never repeats. Understood my point?
Understood, sir.
So next we will go with next one thing. So rational number. I just now spoken about the what is that terminating. What do you mean by terminating? What do you mean by terminating decimal? Let me
Yeah,
write.
means a 2.13, a terminate decimal, not a going on repeating, only a constant value.
Look at it. Tell me whether it is terminating or not.
Terminating, sir, 0.5.
0.5. Very good. It terminates. It stops. After 5, you will not write anything. Correct?
Yes, sir.
It terminates. So for suppose, let's say 1 by 5 you take, it is terminates. 0 point. Clear?
0.8, sir.
Non-terminating, I'll give better for your better understanding purpose. Why beta? Look at this. After 5, you will get exact number. You will get exact number after decimal. That is what terminating. Okay, non-terminating is nothing but what? Non-terminating. What is the meaning of this? Non-terminating decimals are decimals where a digits after the digit. It never terminates. Look at this. For example, you say this is non-terminating. Then 1 by 3 you say better. 1 by 3 is what? 0.33333333 and so on. This also can be written as 0.3 bar. As Harini said, we can write like this. Correct, beta? Simple. Correct. You said 3.3 bar like this. 3.33 bar. Anything is fine. Correct. Understood? Understood my point. Hello.
Yes, sir.
Yes,
So
sir.
this is what non-terminating decimal. Okay. It never terminates. Now if I say this non-terminating decimals can be two types again. It can be recurring or non-recurring. Recurring and non-recurring. Say non-recurring. Recurring and non-recurring. Correct. Recurring is nothing but what? Recurring is nothing but what? Look at it better. Recurring is nothing but after a couple of digits, it repeats the same pattern again. Let's say you write any pattern like 0.1428557 again 1428557 again 1428557 again 1428557. Look at this, the pattern, how the pattern is repeating again. Look at it. This number is again and again repeating or not? Check. Isn't it better? Clear? This is a recurring. Infinitely it goes. It is a recurring. Understood my point? Is it clear?
Yes, sir.
Non-recurring is nothing but what? Non-recurring is nothing but what? Example for this? Pi example. Best example is pi. It never ends. It non-terminates and non-recurs.
And
Very good. So 3.141592. All the different numbers will be there, but it never. I repeat again and again. Recurring is nothing but exactly terminates. Non-terminating is nothing but it never terminates. Okay, it never terminates. It never stops. It never ends. It goes with the same number. In that again, you have two different numbers. Look at this. Two different parts. Recurring and non-recurring. Recurring gives you what? It recurs. Look at it. It gives a pattern. It gives you the same number. It repeats again and again the same number. Okay, but endlessly. It never ends. Non-recurring is nothing but what? It never ends and never repeats. Understand my point? Recurring is nothing but it never ends but repeats. Non-recurring is nothing but never ends, never repeats. Understood my point? Hello?
Yes,
Yes.
sir. Understood.
Yeah. Have you got an idea, everyone?
Yes, sir.
Yes, sir.
Vivek, understood Vivek?
Sir.
Yes, sir. I understood.
Good. What about Dipsika, Satvik,
Yes, sir.
Yes, sir.
Yutika, Yukta? Who is Yukta Sri? Yukta Sri,
Yes, sir.
I would like to see you are talking in the class. Okay, Amatullah, थोड़ा बात कीजिए क्लास में. Amatullah. हाँ, ऋत्विक, प्रणव, नित्या, श्रीकृति. नित्या जी,
Yes, sir.
are you able to understand, beta?
Yes, sir.
Sure?
Yes.
Sure?
Yes, sir.
Pakka?
Yes, sir.
Superb?
Yes, sir.
Excellent.
Excellent, sir.
Good. You understood everything perfectly. Good, 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 good. Chalo. Now let's go for the next one. Okay. Beta, look at this. I'll give one more important. Check. First, suppose I'm giving you one important point now. Check if a given number, given rational number, you write given rational number. Given rational number is terminating or not. Okay. First, suppose let me give an example. If a by b is a rational, number. Okay. Then the decimal expansion, rational number is nothing but what? Then the decimal expansion is what, beta? What is the decimal expansion of this? Decimal expansion would be what? Would it terminate or not?
Yes, sir. Divide.
Yes, sir.
Terminate if both the following, I'll write the two conditions now. Both the following conditions are satisfied. Conditions are, everyone should write, but a very, very important point. Write whatever I'm writing on the screen, everyone. So the number one condition is HCF of A and must be equal to 1. Correct? A and B is 1. So next one. So B can be expressed as a prime factorization of 2 and 5. That is, what is the meaning of this? B can be expressed as prime factorization of 2 and 5. So what is the meaning of this? That is, we can write this as, so B is equal to 2 to the power of m into 5 to the power of n. Okay, where what is m and n? Where m or n is what is? Where m or n are both can be equal to 0. Correct? So now look at this here. Look at this here. If at all, better try to read what I'm trying to say here. Try to understand it properly. Look at this here. A and B is a rational number. The decimal expansion would be terminate. When it terminates, if both the following conditions are satisfied. What is that condition? HCF of A and B must be 1. And which is the meaning of this is, what is the meaning of this? Co-prime. A and B must be co-prime, isn't it?
So here A and
Yes.
B are.
Where is that? Look at this here, 1 second. And B can be expressed as prime factorization of 2 and 5. You take any example, I took 2 and 5, two numbers, which means B can be expressed as prime factorization of 2 and 5. I told, right? 2 and 5, prime factorization. So B is equal to 2 to the power of m into 5 to the power of n, where m, n and both can be equal to 0. Now I'll give you one more statement here. If the prime factorization, I'll tell you better neatly, look at this, prime factorization of B contains any number other than 2 or 5, then the decimal expansion of that number will be recurring. Will be what? Recurring. Understood the statement? Anyone? Do you have understood this, guys? Have you understood this or not? Look at this here. If prime factorization of b contains any number other than 2 or 5, the decimal expansion of that number would be recurring. We'll see an example. You will understand it properly. Like whatever I wrote on the screen, you might not have got the point 100%, but we'll see an example so that you will be understanding it properly. See, let's say that, for suppose you take an example 1 by 40 beta. 1 by 40 is nothing but what? 1 by 40 is what? Is a terminating decimal or not? It is a terminating or not? Tell me.
Yes, sir.
Oh yes, it's terminating.
Terminating.
I need a response from every girl and boy.
Yes, sir.
It is a terminating decimal. How it is terminating?
Terminating this.
1.
So like prime factorization of 40 is 2 cube into
cube into
5.
2 to the power of 5.
0
1.
2 to 5. 0 to 5. Am I correct?
Yes.
It becomes what beta? 0.025. Am I correct? This is what it gives you. Okay.
So,
Now,
but we need to write in the like we need to do LCM, right?
yes.
The
Not
denominator.
yes.
like factorize 40.
No. It's a terminating decimal. As why it is a terminating decimal? As the what was the condition beta?
40.
HCF of 1 and 40 is what beta?
1.
Correct? Yes. Is 1. Correct? Denominator. What is denominator part here?
2 cube into 5.
What was the condition? Yes. Second condition is what? Denominator 40 can be written as what beta?
2 cube into 5.
5 to the power of 1. To the power of 1. What I told you, look at this here. Here, b can be expressed as, that in b is what? Denominator, right? That b can be expressed as prime factorization of 2 and 5 I told. Okay, 2 and 5 I told. 2 and 5. Prime factorization of 2 and 5 beta. So b is equal to 2 to the power of m into 5 to the power of n. You have to represent in terms of 2 and 5 only. So where m could be m and n are both can be 0. So now look at this here. So 40, how can you write in terms of 2 and 5? 2 cube. Look at this here. So 2 square and 2 square is what? 4. 4. So 10 you left with. In terms of 5 powers, you can't write 10. So 2 cube into 5 to the power of 1 is the best way to write. Correct? Am I correct, beta? Any doubts?
Yes, sir. No, sir.
So now look at this here.
No doubts.
So you take any example, beta. Understood or not? Now check. Look at this. So what we wrote here.
Yes, sir. Clearly, sir.
Very understood. Very simple point. If a and b is a rational number, beta, it is a rational number. Why? Because it terminates. So the decimal expansion would be terminate if and only if the both condition, this condition and this condition satisfied. So HCF of a and b is what here? 1 satisfied. What is the number 2 condition? B can be, the denominator part can be represented as b is equal to 2 to the power of m is into 5 to the power of n, where m, n both can be equal to 0, but it should be in the form of prime factorization like this, 2 to the power of 3 into 5 to the power of 1, which makes me 5. Sir, why you are not writing 40 as 2 square into 10? Beta, what I told, it is not looking like 2 to the power of m into 5 to the power of n. It must be in the form of 2 to the power of m into 5 to the power of n. Am I correct? So for writing in such a way, we are using this pattern. Correct? Now I'll give one more example. Shall we go with one more example? Shall we go with one more example? Now look at it. You say 3 by 7. 3 by 7 is a terminating or not terminating? Tell me. I mean, terminating decimal or not? 3 by 7. Check. 3 by 7. 7 ones. 7 0.74s. 2. 7 2s. 60. 7 8s. Tell me whether it is a terminating or not terminating. Check. I need a response from every one of you. Satvik.
Sir, it is sir.
Satvik, are you here, Satvik?
Yes, sir.
But How long were you in the waiting list?
So just like 2 minutes.
Yeah. See, if at all if I'm look, I'll be discussing deeply the concept over here. If at all I don't, accept your request, you can text me at any time, no problem. I will just look at that and accept that immediately. Okay, beta?
Okay, sir.
Yes. So 3 by 7 given to you. 3 by 7 is it terminating or non-terminating? Tell me.
Non-terminate.
Non-terminating, but is it recurring or non-recurring?
Non-recurring.
Non-recurring. Check. Check. 3.4. 3 4s 28. So 23, 14, 16, 4 again 4. 4 is nothing but 3 5s. 5 again 3 7s. 3 1s.
4.
3 4s.
4.
Again, look at this. 4 2. Again, it is recurring or not? Look at this. It is non-terminates and recurring. Look at this. 4 2. Again, it is started. Understood my point?
So, but next digit is 8.
8. So what? Next digit is 8. Okay.
Okay. So 8.
Check. Basic division. Is it a non-recurring or this? Look at this beta. Let me tell you what is happening here. Look at this. This can be 3 0.34s, 3 2s, correct? 6 3 8s, 4. So 4 is nothing but 3 7 5s, again 5. So 50. 7 7s, 1 element, 7 1s, again 3 7 4s, 7 2s, 6 7
8 6
7 8, and so on. Look at this here again, and I'm repeating around 4 2 6 5 7 1 4 2 6 5 7 1 4 2 8 again 5 7 something like that. Is it repeating or not? So it is a recurring. It is recurring decimal, isn't it?
Yes, sir.
But what is the HCF of this? It is a recurring decimal, beta. What I told, terminating decimal, rational number. If A and B, look, what is the condition? What we are learning now? Check if a given number, rational number, is terminating or not. The given rational number is a terminating or not. How can we check? For that, I wrote a rule here. What is that? These are the two numbers. These are the two conditions must get satisfied. Okay. To check whether the rational number is a terminating or not. So look at this here. So if the factorization B contains any number other than 2 or 5, then the decimal expansion of that is recurring. Check. One second. Yes. Now let's see that how it is recurring. I'll tell you why it is recurring, beta. HCF is what? What is the condition number 1? HCF is 1. Perfect. Satisfied. What is the condition number 2? Can you write in the form of? Can you write this as 7 can be written as in the form of 2 to the power of m into 5 to the power of 1? Can you write that? Can you write that? Not possible. Correct. So
No, sir.
simply you can write this as what? Only one way you can write it as 7 to the power of 1. This is the only way we can write. So better look at this here. What was the second point? If the prime factorization of B contains one second, let me tell you. Look at this here. If the one second, very good. If the prime factorization of B contains any number other than 2 or 5. Other than 2 or 5, if it is contains anything, then the decimal expansion of that would be a recurring. Look at this here. It is other than 2 and 5, so it is a recurring decimal. Correct? Understood my point? Understood or not? Yes, Harini.
So we can write like the 1 minute.
You simply.
So we can write 7 to the power of 1. So
Yes.
we can write 7 to the power of 1 into 2 to the power of 0 into 5 to the power of 0, right? Like the denominator. So the second.
So now look at this. It should be in the form of this one, beta.
So it will be enough.
It should be 2 to the power of m, 5 to the power of n. It shouldn't be anything other than that. Mn could be 0, as you told.
Oh.
Understood?
Okay, sir.
Understood? Any doubt beta here? What is the condition number 1? HCF must be 1 and the denominator part should be written as 2 to the power of 5. Sorry, 2 to the power of m into
Only
5 to the power of n. Okay. So if you are able to write like this, then I could say that the given number is what? It is like a rational number. It is a rational number. Okay. And terminating, rational number and terminating. Rational and terminating. Correct? So it was, what was this? 0.025. Am I correct? Something, yeah. Yes, the conditions are getting satisfied. So it is a terminating rational number which is terminating. Now here the condition number 2 was not satisfying, so it is a recurring decimal. Correct? Understood my point? Understood the process better?
yes.
Yeah. So shall we go for the solving questions now? Shall we solve the questions? So we done with the introduction. We gone through the introduction perfectly. Understood? So now we will go with the questions. Any doubt, guys? If you have any doubts, you can ask me. Any doubts? Satvik, Nitya, Modita. Modita, I don't see your like responding in the class. Any doubts, Modita? Modita ji, any doubts?
Not right now, sir.
Sorry?
Not right now, sir.
Can't hear you, Modita.
Not right now, sir. Sir, not right now.
Okay, you don't have any doubts. Kavya, Shreyan, Dipsika, Krishna, Bhumika, any doubts? Aditi, Akshara. I don't see Akshara also not speaking
No,
today
sir.
in the class.
No doubt, sir.
Good. Perfect. So make sure that you all are like, just what I taught here, what we learned, what was the concept, check if a given rational number terminating or not. I mean, rational number is a terminating
Yes,
or
sir.
not. What is the condition for that? The first condition is HCF must be 1 and the denominator part I must be able to write in the form of like this. If at all I able to write that, so I could say that that is a rational terminating number. I mean terminating decimal. Rational number with a terminating decimal. If at all I am not able to write like that, anything other than 2 or 5, Harini, he was asking, look at this. Any number,
Yes, sir.
any number other than 2 or 5, then the decimal expansion of the number will be recurring. Yes, very simple. Other than 2 or 5, we had 7 something. So it is a recurring. How simple it is? Very simple, beta. Very simple
Yes,
language
sir.
I wrote here. Okay, chalo. Next. Am I going fast?
No, sir.
I need a response from every one of you. If I'm going fast, I'll go somewhat slow. If you're not able to follow.
No, sir.
The pace is fine.
Yes, sir. Yes, sir.
What about others? I need a response from everyone.
Yes, sir.
Yes, sir.
Leaving. Very good, Ritik. Let's solve this question and let's wind up the class. Find the larger number that divides 70, 125, leaving the remainder 5 and 8 respectively. Find the larger number that divides 70 and 125, leaving the remainder 5 and 8 respectively. But a very simple. Did you find the answer? You should not take this much of time. Very simple. I'll tell you a trick for solving this. Trick. What is the trick? Trick. Time up.
Someone can I check my answer?
Okay. Very good, Aditi. Right answer. Those who have not Those who are not able to solve this, you can follow the method called IDK. Yes, quick. Don't waste my time. If you do not get an idea, post a message called IDK. Okay, Harini, I'll teach you. Quick, 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 quick. What happened? I don't see many IDKs. So Dipsika, Bhumika, very good Bhumika. Satvik, I'll teach you Satvik. Dipsika, I'll teach you. Don't worry. Harini, okay. So yes, Ritvik, I'll teach you. Look at this here. Here, find the larger number that divides this one and this one by leaving the remainder 500 respectively. So basically what you have to do is 70. What is the remainder leaving you? 5. So subtract that. What do you got? 65. 125. What is the leaving remainder? 125 minus
8.
What you left with? 113.
117.
You need to find a larger
117.
number. Larger number is nothing but what? Find out HCF. Y is the common factor. That's it.
Sir, that's 7, sir.
Yes, 7, sir.
Which one?
It's 117.
125 minus 8 is
Oh,
117.
yes, 117. I'm sorry. So what is the larger number? It's nothing but HCF of this. What HCF of 117?
So 13. I think.
What you left with? What you got here?
So
How do you find out
65 is
How do you
3,
find-
5
how-
into 30.
Yes, 117. What is the greatest number? 65 ones. 65. So what you left with? Beta, how much? 35. 35
52,
plus
sir.
42. No, 35 plus 70. 52. 52. Correct.
Yes, sir,
Again, I have
52.
to go with 65 here. So 65 ones 65. Sorry, 52 ones 52. So 30. This is my HCF now. Do you know how to find out this HCF by using box method?
Yeah, sir. Long
Right.
division method.
Yes.
A long division method you can go, or else you can follow. You take a greater
Lemma.
number.
So we can also follow prime factorization.
Prime factorization you can follow. Multiple methods.
And also lemma also.
Lemma also very good. Lemma Euclid lemma division method.
Yeah.
Okay. Any doubts?
No doubt, sir.
Basically, Euclid's lemma division method we use for finding HCF only. That we just learnt in last class. Okay.
Yes, sir.
Clear, beta? Any doubts?
Yes, sir. No doubt, sir.
Any doubts? Akshara, any doubts? Modita, any doubt? Nitya, Srikruti, any doubts? I think Amatullah, any doubts? Any doubts? Bhumika, any doubts?
No, sir.
Bhumika, any doubts?
No, sir. No, sir.
Okay. Akshara. I think Akshara is not here. She is here.
Yes, sir.
Okay. All right, beta. Thank you. So your homework is, you know the homework, right? Worksheet.
Yes, sir.
Yeah, sir.
What is the homework?
Worksheet.
What is the homework? From which sum to which sum?
The next 10 questions.
Huh? Next.
Solve till 22.
You solved till 22, right? Okay. Next, level
Yes, sir.
3, level 3, 1 to 8 questions. I'll show you on the screen now. Look at this here. I'll show you 1 to 8. I'll post in the group now.
And so please post the result as well.
Yes, I'll post it. Okay. Okay, children, that is your homework. Today's homework is, this is what your homework. Where is that about? Yes, here. 1 to 8. Can you see that? These 8 sums, level 3. I'll post the homework. Okay. Thank you. I'll post the results very soon. Means I'll post it now. Thank you, beta. Goodbye.
No, thank you, sir.
Thank you, sir. Thank you, sir. Bye, sir.
I actually have headaches, so I couldn't answer.